Section 1.1, identify points, lines, and planes. So our goal for this section is to be able to name and sketch geometric figures. So our first example here we have is called a point. And this would be read point A, for example. So note about a point, it has no dimension. And when labeling, we always label with a capital letter. As we can see here with point A. Our next term is the line. A line has one dimension. And there are several ways to name a line. One common way that we do is we name the 2 points that a line goes through. So for example, we have here BC. The thing about naming a line is we have this notation that goes over it with a double arrow. That is the line notation. Now the question is BC the same as CB? And yes, it is. You are talking about the same line that goes through the points. The biggest thing to note about a line, it is never ending. It goes on and on without end. That's what the arrows mean. The other way you will see them is with this lowercase italic letter. In this case, it happens to be K. It's hard to write italic. Italic is more of a text thing, but in your textbook you will see a little gray or light blue italic letter. That is also another way to name a line. Alright, next is the plane. A plane is two-dimensional. So we say it has two dimensions. It's kind of like a wall or a floor, but never ending. So we say that extends without end. When naming a plane, there are a couple ways to name it. One is by this capital letter in the corner. So we could say that this is plane D. Most times this capital letter will also be bolded. Not always, but most. Another way to name it is by 3 points. So as we see here, we can use 3 points to name a plane as long as they are not on the same line. You'll hear me use the phrase, through any 3 points exists a plane. What we're saying is any 3 points that are not on the same line. And we could name a plane. So for example, if we had point E, point F, and point G, we could say this is also plane EFG, the plane that goes through those 3 points. Which brings us to our next term, collinear. Co is the prefix meaning to share or with. Linear meaning line. If they are collinear, they are on the same line. And thus coplanar are on the same plane. Where we'd use coplanar, for example, the front wall and the floor are two planes. They meet at the piece of trim. That piece of trim is coplanar. It is on the same plane as the floor and wall. Another example would be the feet of your table and the feet of the desk you could be sitting at. All those feet are all on the floor. They are all on that same plane. Two other terms you hear in this unit as well, or in this section. First one would be a line segment. Typically, we would just say segment, but you will also hear it referenced as a line segment. The big thing about a segment, it has a beginning and an end. So we say it has two endpoints. When naming this segment, the notation is very similar to line, except it does not have the arrows. And just like a line, you can name it either direction. So EF and FE are in fact the same segment. Where they are different, or where there is importance, is on a ray. So a ray has one endpoint, and then an arrow, so it continues in the opposite direction without end. When naming a ray, you start with the endpoint, the starting point, or the initial point. In this case, G. And then you name the point in which the ray goes through. In this case, H. And then you draw what looks like a segment with one arrow. And we always start with the beginning, your initial point it goes through. We always draw a ray going to the right. Our last term is opposite rays. Opposite rays are two rays with the same endpoint or as we called it, the initial point, that go in opposite directions. You'll note that when you see them, they form a line. So if I have one ray, in order for it to be an opposite ray, it has to go from that point and continue on. I would say that pretty much that the blue ray and the green ray together make a line. These would be an example of opposite rays. This blue ray and this red ray clearly do not make a line, so they are not opposite rays even though they share an endpoint. They have to be same endpoint and make a line. Take a moment, copy this diagram and name an example of each. Alright, an example of a line. You could have the lowercase italic j, the K, You could say NG, GN. There are multiple examples. And to note, when you see on this diagram where do not have an end point, we are to assume that they continue off the diagram as they are. So we will draw these arrows in. Point any of these where you see the red dot, those are points. So N, G, H, J, M, I, K, or L. Any of those work. I'll just say N for example. A ray. We could have NG, so you could start here at N, continue through G. You could also go the other way. Starting at G, you could go through N. That works. And there's also starting at J and going through I. Those are all valid examples of a ray. Segment, you could have NG, GN, JH, HJ, MJ, JM, MH, HM, IJ, JI, or LK, KL. Any of those work. Pick whichever one you would want to use. Make sure you use the notation. Plane. When naming a plane, you need to write the word plane. You've got plane M, plane N, or you could pick any three non-collinear points on plane M. 3 collinear points. 3 collinear points would be 3 points on the same line. Only way to do that is M, J, and H. Coplanar, what are points that are on the same plane? Pretty much all of these points are on M, so you can pick any 2 things on that. So let's say M and K. Does it have to be points? No, you could say point M and segment LK are coplanar. Alright, sketching lines and planes. Make a sketch of 3 different planes and label as T, U, and V. To sketch a plane, we simply draw what appears to be like a parallelogram, and then we will label in the upper corner. So we've got T, U, and V. Please make sure that your U's and your V's do not look the same. Again, we are doing sketches. Are they all perfect? No, as you can see by mine, they are all different size, slightly different shapes. That is perfectly fine. Draw a line in plane T, not in plane U, and through plane V. So we will start with in plane T. To be in the plane, simply draw it such that it is in the parallelogram shape you drew. Not in a plane. Draw it outside of it. To show through a plane, what we will do is show the point which it goes through, a solid line for what we would see above the plane, and a dashed line for what is below, showing that there is, in fact, going through, like a pencil through a piece of paper. Alright, and the last thing I ask you to do, draw 2 planes, planes A and B, such that they intersect. What we will do is we will draw a vertical parallelogram. Here is our plane A. We will draw a horizontal parallelogram. Call this one plane B. And now the question is, where do they intersect each other? This can be difficult to see, but those 2 planes right there share. That is where B goes through A or A goes through B, depending on how you are looking at it.